All right, so there are some basic trig identities that we're going to use to prove two things equal. Some of them you already know. So some of the ones you already know are the reciprocal identities. And there are 6 of them. And these are ones that you need to have memorized, but the good news is you already have them memorized. So that would be like sine of theta is equal to 1 over what?
1 over cosecant.
Cosecant, beautiful. It's 1 over cosecant theta. Okay? And then that, of course, means that cosecant theta is equal to 1 over what? That's right. Okay, so if you think you know the other ones without me, go ahead and fill those in. Cos theta, tan theta. Cosine's the reciprocal of which one? 1 over secant theta. And so secant theta is 1 over cosine theta. All right, tangent is 1 over, what's the reciprocal? Cotangent, good. And then cotangent is 1 over tangent. All right, so if you already knew those, raise your hand. Let's see who already knew those. Okay, if you think that you weren't 100% sure of that, but it's kind of easy to pick it up now, raise your hand. All right, that's most of us. If you didn't have them before, though, you're going to have them now because we're going to be using these to prove different identities. So 6 reciprocal identities. Then we have 2 quotient identities. These you kind of know, but you're going to pick them up real fast. Quotient means what? Identities. Divide, right. So it means if we divide 2 trig functions, we're going to get another. Do you guys remember on the unit circle, we said that the tangent of theta, oops, you can't see that, was equal to y over x? Do you remember that? Mm-hmm. Well, on the unit circle, the y is the same as what trig function? Sine. And the x is the same as what trig function? Cosine. So instead of saying that the tangent is equal to the y over the x, you could say it's equal to the sine over the cosine. And since we know that cotangent is equal to x over y, what ratio could we put here? Exactly. Cosine theta over sine theta. So remember, guys, the theta, that's just your variable for an angle. You could put x there just as easily. We use thetas a lot in trig identities. All right, and then the last part is a little trickier. Those are the Pythagoreans. So we're going to set up a little triangle to explain the Pythagoreans. Pythagorean identities. 3. So guys, these we're also going to memorize, but when you forget them, they're easy to figure out. So you draw a triangle in the first quadrant, and this triangle is going to be on your unit circle, so the hypotenuse is going to be 1, and this side is on the x-axis, so that's x, and this is measuring in the y direction, so this is y. So I just want you to write the Pythagorean theorem for this triangle while I pause for just a second. All right, so Pythagorean theorem would be y squared plus x squared equals 1 squared, which is just 1. So what could we substitute for our y? What trig function? Sine, yeah. So we're going to put sine squared theta plus, this is going to be cosine squared theta, and that equals 1. All right, so here's the tricky part. This is one of our 3 Pythagoreans. The other 2 you can find by dividing. So if I divide both sides by sine squared theta, what do I get? Sine squared over sine squared is what? 1. Plus cos squared over sine squared is going to equal cotangent squared. Well done. Okay, so I'm dividing everything by sine squared. Sine squared over sine squared is 1. Cos squared over sine squared gives me cotangent squared. And then 1 over sine squared. What's that going to give us?
Is that cosecant?
It is, right. So 1 over sine squared is going to give me cosecant squared theta. So it's going to equal cosecant squared theta. So this is another one. So personally, I often just remember this one, and then if I need to deal with cosecant and cotangent, then I just divide everything by sine squared to find the new one. And then, what if I go back and instead of dividing both sides by sine squared theta, I divide by cos squared theta? Just divide. All right, you're way ahead of me. Let's see. All right, so Meredith says sine squared over cosine squared is going to be tangent squared. Good. Okay, and cos squared over cos squared, I agree, that's plus 1. And 1 over cosine squared, I heard a couple people. Anybody else? Yep, 1 over cosine squared is secant squared theta. Okay, so these are all the tools that we need for today. Let me go back like this. Okay, these are all the tools that we need for today. And they are actually nice and neat on the back of your calendar. They're right here. But the reason we wrote them out is because we need to be able to figure them out. So like if you forget that tangent sine over cosine, you can go back to your notes and remember, oh yeah, it's because tangent's y over x. That's why it's sine over cosine. If you forget the other two Pythagorean identities, after sine squared plus cos squared equals 1, you can remember, oh, I can figure them out by dividing by sine squared or dividing by cosine squared. These over here, we're not dealing with these yet. We're just dealing with these for now, okay? These will come into play later. And notice on your calendar it says memorize, 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 and then it stops saying memorize. We're not going to have to memorize the rest of these. Yeah. Yeah, I'm going to pass you the other one anyway. Okay. Any questions on these before we move to our big list and start proving identities?
Do we get the big list on the unit test?
So the big list doesn't actually help you with anything. These are problems. This is just like a list of problems. Okay? On the unit test, though, you will get not the ones that you can memorize, but the other ones on the back of the calendar. Okay? So the big list, these are actually problems, 142 problems. All right, for the big list and for any trig identities, you always have to work them on a separate paper and you have to copy the problem over. So hopefully you already have paper out for your notes. So you are going to take out a new sheet of paper or work on the same sheet on the back maybe. And we're going to work through some big list problems. Yes. You guys done with this?
Why did you write that error?
Here. So I started with sine squared plus cosine squared equals 1, and I divided both sides by cosine squared. So sine squared divided by cosine squared gave me tangent squared, and cos squared divided by cos squared gave me 1, and 1 divided by cos squared gave me secant squared theta. All right, so on your new sheet of paper, we're going to do problem 1 from the big list, so we're going to copy it over. Sine theta, secant theta.
Do we have to write the theta?
Yeah. So guys, when we're doing trig identities, you are getting graded on your format. I already know the answer. It's right here. Okay? I'm giving you the answer. That's the way it is with all proofs. You're trying to prove something true. So I already know what I'm going to make it equal to. So what you're getting graded on is the format. So here, let's just write down tips as we come across them. Yes, you have to write theta. You will lose points if you don't. You have to write theta in every step. Okay. You're trying to change one side to look like the other side, and you may only change one side. You can't change both sides. So let's write that one down too. You may only change one side. And generally, it's more easy to change the complicated side. So I'm going to say, as advice, start on the complicated side. Not a rule, but advice. Change the complicated side. All right, so we need to change sine theta, secant theta into tangent theta. Anybody have an idea about how to do this? Danny?
You gotta convert it to, y and 1 over y.
Mm-hmm. So secant is 1 over x, and sine is y.
Right, secant.
Mm-hmm. So I like the way you're thinking, but when we do trig identities, we don't usually change them back to the x and y, but writing all that stuff down could help you think through the problem. Anna?
Can we do a quotient identity and do tan of theta equals sine of theta over cosine theta because secant is 1 over cosine of theta?
Okay, so I like where you're heading with that. Now remember, we can only change one side. So what if we change the secant to the, so I'm not going to change the left and the right, just going to change one side. So let me see if I can head in that direction by changing the secant theta to 1 over cosine. Okay? So we're going to follow Anna's advice. We're going to change secant theta to 1 over cosine theta. So another rule, you have to write everything in every step. I can't just write that. I have to write everything. Okay, so I have to write the sine theta and the equals and the tan theta. Okay, so could I combine sine theta times 1 over cos theta into one fraction?
Oh my goodness.
Yep. All right, so do you think this is true?
Mm-hmm.
Okay, your very last step, go ahead, Anna.
So you can't go just from the first one to the last one.
Right.
You have to write the
You have to write every step. Think about geometry proofs, how you had to show every little step. Jessica?
Are the proofs can be wrong ever that we have to prove it, or is there?
Oh,
'Cause you're
not,
just-
right, not on purpose. I think at one point there was one in the big list that didn't work out. It was like near the end, but I think we fixed it.
Okay.
Yeah, so in general, I think they all work. All right, do you see how your last line has to be tan theta equals tan theta? You can't just stop when it seems obvious to you that they're equal. You have to stop at something equals itself, okay? So the last line is always something equals itself. Okay, so you guys now try number 2. Number,
Can you see the notes that you wrote
oh, on here? Yeah. Okay, so you guys are going to try number 2. Number 2 is similar to number 1. In general, on the big list, a number, the number next to another number, those are going to be similar. There you go. Remember, you can only change one side. Is that on? Only change one side? right? Okay. All right, you finished?
Oh.
Have you done this problem yet?
That's the green.
Okay, you need to do the crossword problems. All right. Good.
I really have no clue what she did, so I just don't want to do it.
So you change the first one to one sign, but you still have to write if you don't see the practice of doing the steps right for your notes, then you have to Okay, so I like what you're saying, you're doing good thinking.
Why are we doing this? What is the point of What is the point of this?
Okay, go there. I already answered your question.
I see. So maybe
You have a
I
question?
should seek it.
This is
Yes, but trying not to run over as part of the format is also just doing everything vertically, okay? So over here, you just build a funny room. Not a good time. Let's do a few more problems first.
I did,
All right, guys, who wants to share their work for this one before we move on to another one? Let's see. All right. Cosecant. So you have to rewrite the cosine data equals cotangent data. You have to write everything on every line. Okay? And then here, you don't want equals theta, it's going to be cotangent. Remo, can I see yours? You take Remo's this time. Oh, thank you.
Yeah.
Perfect. Hey guys, if anybody else has the reflection that you haven't turned in yet, make sure you give that to me, okay? All right, guys, for number 2, take a look at Remo's work. He changed the cosecant theta to 1 over sine theta. Oh, I froze it. My bad. Thank you. And then he combined the 1 over sine theta with the cosine theta. And then he changed that to a cotangent theta. So notice that the right side says equals cotangent theta for every single step. And notice that he didn't leave anything out. Like when he changed the cosecant theta to 1 over sine theta, he still copied this one down. Anybody have any questions on this one before we try a new one? Okay, so this is new to us. I understand that we're learning the format. But if you have any questions about format, please ask me, because if the question is, do I have to, the answer is usually yes. Okay, so I'm going to freeze that one for a second, because some people are still trying to see his work. Here you go. Not yet. Okay, so we're going to do number 5 next. So copy number 5 onto a sheet of paper. Okay, so I want you to take a minute to discuss with your group what kind of identities you think you might want to use here. If you're going to use reciprocal identities, quotient identities, or Pythagorean identities, and then how you might do that. So take a minute to talk to your group about that. I heard a lot of votes for the Pythagoreans there, and I do think the Pythagoreans are going to be most successful, but I heard some confusion over how you would apply them, and I get that, I understand. I have sine squared theta plus cos squared theta equals 1. Is there any direct substitution I can do there? Thanks.
So we do
Yeah, so the Pythagorean that seems to apply here is this one. Sine squared theta plus cos squared theta equals 1. Is there anything I can directly substitute in here on either the left or the right side? So I don't have a sine squared plus cos squared, but do I have a 1?
Yeah.
What could I change the 1 to? Well, on this sheet here, it says 1 is exactly the same as what? Sine squared theta plus cos squared theta. So couldn't I change the 1 into sine squared theta plus cos squared theta? I could. I know that it's...
Negative one.
Right, so I need to put a minus in front of it. I totally agree. That's right. Okay. So if I copy this side over, 2 cos squared theta minus, and then instead of the 1, I would substitute sine squared theta plus cos squared theta. Okay, and I'm going to actually highlight what I changed there. It's not a necessary thing to do, but it's kind of helpful when you're trying to follow along a proof. Like, what changed in that? I changed the 1 to sine squared theta plus cos squared theta. Now I still have to write the other side. So now I've committed to changing which side of this, the left or the right?
Right.
Yeah, I've committed to changing the right, which means I have to leave the left alone. All right, so if I distribute that minus, I can show that. 2 cos squared theta minus sine squared theta minus cos squared theta. All right, do you see any like terms I can combine?
Yeah,
What are they?
the cosine squared theta is on the right side.
True, right. So if I have 2 cos theta minus 1 cos theta, what does that give you?
Just
Cos squared theta, yeah. 2 cos squared theta minus 1 cos squared theta is cos squared theta. And then I still have minus sine squared theta. And now they're the same, right? Nice. Okay, so that one did end up working out for us, and you can give yourself like a little check mark at the end to say, look, I did it. That one did work out for us, but sometimes the sine squared and cos squared, the Pythagoreans, sometimes they're just not set up in a way that is going to be helpful for that. So let me show you other ways I use my Pythagoreans, and I'm going to write them right here on my formula sheet, okay? So I do know that sine squared plus cos squared equals 1. And because these are proven, these are all proven, I am allowed to change these. I can only change the proven ones on this page. I can't change my problems. So because these are proven, I could change this to be cosine squared theta equals 1 minus sine squared theta. All right, because you see how if I subtract sine squared from both sides, I get that. Or I could change this to be sine squared theta equals 1 minus cosine squared theta. So from this one, I could actually use all 3 of these. So when you guys are working on problem 6 next, one of those might be more helpful than just substituting for the number 1. Or you could just substitute for the number 1. That might work too. So you could try to do the exact same thing and change the number 1 to sine squared theta plus cos squared theta. Or you could use one of these substitutions here. So I'm going to give you a minute to try problem 6. All right, so we're going to look first at Maha's method. And Maha changed the cosine squared to be 1 minus sine squared. And then she distributed the 2, so she had 2 minus 2 sine squared. And you can see she underlined the like terms that she combined. So 2 minus 1 makes 1. And then both sides are the same. Now notice her format. Every single line she brought down the same left side. I'm going to try to zoom that a little bit. Okay? Who has questions for Maha about her method? Go ahead and ask her.
Well, I mean, I guess it's for you, but why is it 2 sign and not 2 minus sign? You see what I mean?
Why is it, oh, instead of 2 minus 2 sine squared theta, you have 2 minus sine theta? Is that right?
Yeah, actually, no, I see what
You do? Okay. Any other questions on this method?
I
So-
started from the wrong side.
Okay, no, there's no wrong side, because I'm going to show you the other side too, okay? I think this method might have been the easiest way to do it because you didn't have to distribute a negative, so there's just less chance for error. But there's more than one correct way to do this problem. I see a lot of you still looking at our method, so I'm going to leave that up there, and then I'm going to show you Meredith's method, and Meredith replaced the sine squared instead of the cosine squared. You only have to do the problem one way. Is there anybody who thinks that they did it correctly by replacing the 1?
I'm doing it.
Yeah, it's possible to replace the 1, but I believe it takes multiple substitutions, so it's a little bit harder.
Can't you do it like you did it where we did number 5?
Possibly. We'll see.
Probably not.
Alright guys, so I am leaving that up for a minute to make sure everybody has it. If you're thinking ahead, I'm going to do 11 next, okay? Alright, so here's Meredith's method in the same screen. It's a little lighter, so if you need to get out of your chair to see it, that's fine. But what she did was she replaced the sine squared theta with 1 minus cosine squared theta.
Just where I can't see.
Okay, just move closer. So she replaced the sine squared with 1 minus cosine squared, and then she distributed the negative 2, and then the 1 minus 2 gave her a negative 1, which she put here at the end so that the two sides would match. And then notice again how her format brings everything down each time. So you don't need to write down both methods. One method is fine. You just need to understand one method. Does anybody have a question for Meredith on her method? And does anybody think they have another way to solve this that worked on their paper? Yeah, share it with us if you come up with it later. But for now, we're going to move on to problem 11. So write down problem 11. In problem 11, which side is more complicated, the left or the right? The left. So I'm going to suggest that you work on the left. I'm going to return these papers. So copy number 11 down and try changing the left side. It's a challenge because we haven't done one like that before. Thank you. Thank you. Josh, did you already do 11? 11's our last classwork problem, and then we're going to just work on homework problems after that, okay? Did I steal somebody's paper? I have blank paper on my desk. Is that nobody's? I'm going to use it then. All right, number 11. 1 minus sine theta cos theta tan theta equals cosine squared theta. All right, any suggestions for what we could try here? What could we change? I could change tangent to 1 over cotangent. Will that get us closer to what we're trying to make? Probably not. I could change what?
Cos to 1 over secant.
So I could change cosine to 1 over secant, but you know the cosine's actually the one thing I want to hold on to because see how I'm trying to get cosine squared? Wait, let's, okay. Hands guys, I heard a lot of ideas at the same time. All right, Michael?
Oh, you can change the 1 to sine theta.
Sine squared.
Sorry, sine squared theta and cosine squared theta.
Okay, Christina, were you going to say the same thing? Change the 1? Okay, I think that might be on the right track, but I'm wondering, because I don't have anything to combine with that yet, maybe I'm going to hold on to that idea and do it in a few more steps. Meredith?
Could you change tangent to sine theta over cosine theta?
What do you guys think about changing tangent to sine theta over cosine theta? So, Anna, were you going to say the same thing? Uh-huh. And Danny?
I was thinking that you could do both because the sides will be able to cancel out.
Okay, so some of you are thinking ahead multi-step. You guys must be like chess players. Okay. So I think I'm going to take Meredith's idea, and I'm not going to do 2 changes in the same step because it gets complicated to understand what you did. But yes, I'm going to do Michael's idea of changing sine squared plus cos squared from the 1 later. I'm going to save that one for later. I'm going to start with Meredith's idea of changing tangent to sine over cosine. So this is going to be sine theta over cos theta, and everything else is staying the same.
Should we just start with that if we see the tan or cotangent on one side?
Well, it's possible that you have to change the tangent or cotangent to its reciprocal. The way I always think about it is I look at what I'm trying to make. I'm trying to make a cosine squared. And so getting more cosines could be helpful. Except what happens here when I get more cosines? What happens with my cosines? Yeah, who said that? They cancel out. That's right. They do cancel out because I have 1 on the numerator and 1 on the denominator. So they do cancel out, but it's not all bad news. Let's see what we get out of this. So those cancel, and I have sine theta times sine theta, which is what?
Sine theta squared.
Yeah. So sine squared theta equals cos squared theta. Now, we do know we could change this directly to cos squared theta from your list, but I kind of like Michael's idea from the start because it's a little bit nicer to use this identities without the change if it's possible. So if I take Michael's idea and I change the 1 to sine squared plus cos squared, it just adds 1 step in here. So my 1 is going to become sine squared theta plus cos squared theta. And then I bring down the minus sine theta, squared theta. Okay? So what I did in that step was I changed the 1 to this. And now I have sine squared theta and minus sine squared theta. So what am I left with on my left side? Cosine squared theta.
But you could have just solved it before.
I could have just done it in that 1 step, yeah. But it's more pure mathematics to use one of the Pythagoreans from the original.
The 2 signs cancel each other out.
Yeah, because you have a negative sign and a positive sign. That's true. Okay, so guys, good job on your first day of proofs. At first, they seem really overwhelming, but the more you do them, the better you get at them. So I do want you to start in right now the homework assignment, which is big list 3, 4, 7, 8, 9, 10, 14, and 16. And as you're working on them, if you're having a lot of trouble, plan a time to come for help. That would probably be after school tomorrow or before school tomorrow, because today after school I have a meeting. Okay?
Wait,